Page 10, we're going to finish up our lesson on rational numbers as decimals. So looking at changing repeating decimals into fractions. So on page 10, if we look at number 4, a survey reported 63.63 repeating percent of moviegoers prefer action films. This percent represents a repeating decimal. Write it as a fraction. This problem is a little bit different. This is a percent. So the first thing we're going to actually do is we're going to change that percent to a decimal. You might remember to change from a percent to a decimal, we're just going to move our decimal point 2 places to the left. So like for example, you guys know, just to show you how this works, 70%, the shortcuts just move the decimal 2 spots to the left. The reason why that works, 70% would be 70 over 100. 100 is like 10 times 10. Every time you divide by 10, your decimal moves 1 spot to the left. Or you could just look at it as 70 hundredths, as a decimal is 70 hundredths. And then just look at, here's where we started, here's where we ended up, what happened. Basically, our decimal moved 2 spots to the left. So what we can do for this problem is we can say it's like this. If we just moved our decimal over 2 places. This is a little bit redundant though, a little repetitive, more so than what we need it to be, because if you'll notice, right before we have the bar that's got the 6.3 over it, we have another 6.3. So it'd be 0.63, 63, 63, and so on. So really, to make this look more like what we've been talking about, we can go ahead and just rewrite it this way, where we have the decimal right, or the repeating sign right after the decimal, and that will allow us to then write this as a fraction. It's got 2 digits after the decimal point, so we can write it as 63 over 99. We're not quite finished with this problem. One thing we haven't really talked a whole lot about yet maybe, but anytime with fractions we want to try and reduce if possible. So 63 and 99 are both divisible by 9. And if we reduce both of those by 9, that will take this down to 7/11ths. 7/11ths, 7 and 11 don't have anything in common other than 1. If we divide them by 1, it's not going to help us out any, so we'll just leave it right there. 7/11ths. And a way of checking these problems, if you guys are doing your homework and stuff, if you want to check this, what you can do is just on your calculator, you can do 7 divided by 11. And you should get 0.636363 and so on. We've talked about it before maybe, but that last digit, the calculator might be rounding off. So just depending what the last digit happens to be, it might have rounded it up just because it's just rounding the last digit off. We're going to look at a few more problems here on workbook page 1. So workbook page 1, number 1, they want us to write that decimal as a fraction. Like we've talked about, since it's repeating right after the decimal, we actually don't have to go through this whole process of what the book's doing. We can actually go straight to this little trick we've talked about and get that as a fraction. So it repeats right after the decimal. It's got 1 digit, so we just put the part after the decimal as our numerator. And since it's just 1 digit repeating, we can put it over 9. So 2/9, that can't be reduced, so that would be our final answer for number 1. Number 2, same thing. They didn't write it this way, but if you'll notice, after the decimal, they've got 888 ... That means it just keeps going. So that they could have written as 1.8 repeating. And so again, it repeats right after the decimal. So we're just going to go straight to using that trick to get our answer here. This one a little bit different is that we have a whole number part. So we're going to put our whole number part in front. And then the fraction, the part after the decimal point, we have an 8. It's just 1 digit. And so we put it over 9. So 1 and 8/9, that can't be reduced, so that's our final answer. So number 4, similar idea. This one happens to have 2 digits that repeat, and again it's right after the decimal point, so we don't need to go through that whole process. So this would be 12, that's our part after the decimal, over 99. Kind of a way of remembering it, however many digits you have after the decimal that are repeating, that's how many 9s you need. So basically just write a 9 directly below each digit in your numerator and you'll be in good shape. This problem actually is one that would be able to be reduced. Both of these numbers are divisible by 3. Which would be 4 over 33. At that point we can't reduce that any further, so that would be our answer. So we're going to look at number 7. They want us to write this as a fraction. So this just has 1 digit repeating right after the decimal, so we can write that as 7/9, and that can't be reduced. Now if we look at number 8, a reporter determines a baseball player's batting average, which is the ratio of number of hits to the number of times at bat. The result is shown on the calculator as 0.2121 and so on. Write this repeating decimal as a fraction. Usually with batting averages, what they do, they just round it to the nearest thousandth. So they would say, you know, his batting average, they would probably just do this and just say he's hitting 212 is how they say that. But anyway, for the sake of this problem, we'll go with it. So we can write this as a repeating decimal first. So we put our decimal point, and the 2-1 is what's repeating. So if you want to just write it one time here, 0.21, and then put a bar over both of those. And now we're ready to write this as a fraction. Understand that's not our answer yet, but that's kind of what we're used to seeing before we write it as a fraction. So since this has 2 digits repeating after the decimal, we'll just match a 9 underneath each of those numbers. So that's 21 over 99. And we can actually reduce both of these by 3, and that would be 7 over 33. We can't reduce it any further, so that would be our answer for part A. Part B asks how many hits would the player be expected to get in 200 at-bats. So what we could actually do for this is we could say they would get about 7 out of 33. We could do a proportion if we wanted to. If they get like 7 out of 33, we're trying to figure out how many hits they would get out of 200. This would be one way to try to work this out. Trying to do this, these numbers aren't the nicest ones to work with. You know, sometimes we try and find patterns and like take 200 divided by 33, and that's like a repeating decimal answer. You can still keep it in your calculator and work it out that way. Otherwise though, you could just say x is being divided by 200, so we could just multiply by 200 on both sides. And then, so 1,400 divided by 33. So that would be 42.42 repeating. Probably they're not going to get like 0.42 repeating that part of a hit. So what we would do then is just round that off. So we could say maybe about 42 hits that they would get out of 200. So we look at number 9 is repeating right after the decimal again. So we can put that as 32 over 99. That actually can't be reduced, so that would be our final answer for that one. And then if we look at number 10, number 10, we've got a whole number part, so that goes out in front, and then we have a 5 right after the decimal that's repeating, so we write that as 2 5/9, and that can't be reduced, so that would be our final answer. we've done a lot of things with looking at repeating decimals and how we can write those as fractions. What we need to make sure we don't lose track of is if we get to a problem that's not repeating, that we still remember how to do that. And probably the best way is maybe just think about how we could read this decimal. So we could say this is 74 hundredths, and that means our fraction we could write as 74 over 100. At that point, it's just a matter of reducing if we can. So like these are both even, so we can reduce both of them by 2. So that'd be 37 over 50, and then we can't reduce that anymore. Okay, so just remember, you know, if you get a fraction and it's not repeating, just go back to that idea. This would be 8/10. So 8/10, and then we can reduce that down to 4/5. Okay, so you might see a combination of both of these types of problems. So this gives you an idea of how to work with repeating decimals, changing them to fractions.